What if the biggest challenge, maybe the real challenge, in building something like artificial superintelligence, ASI, isn't just how fast we can do it, but how safely we can do it? How do we make sure this thing that could completely change everything actually helps humanity, doesn't, endanger us? That feels like the really big question. And it's what we're diving into today. We're going to unpack a pretty comprehensive strategy for building ASI. It's drawn from a detailed report, synthesizes a lot of the latest AI safety thinking, strategic thinking. Our mission, really, is to get into what some are calling the ultimate strategy for building aligned ASI.
Yeah, and what's really striking, I think, is how it shifts the whole conversation.
Yeah.
It's not about this, reckless race to the top, who gets ASI first no matter the cost. This is different. It's multi-layered. Safety first is baked in right from the start. Co-evolutionary. It's really focused on getting an intelligence that's beneficial and crucially controllable. It's a genuine paradigm shift from a lot of the current chatter.
A huge shift. And the report lays it out in these three connected stages. There are the foundational prerequisites, then a synthesized construction method, and finally, a guiding philosophical framework. It really pushes back against this idea that it's just one single build. It's much more intricate than that. Okay, let's unpack this core idea first, because it kind of flies in the face of, well, a lot of what's happening out there. It's saying the goal isn't just building intelligence like brute force, bigger model, more data, that whole thing, but actually cultivating a very specific kind of intelligence through a really carefully sequenced, constrained process. So the how is just as important as the what. Like you said, gardening minds, maybe, making sure it grows right.
That's a good way to put it. And this cultivation, it has these three critical mandates, almost like guardrails. First, solve alignment first, period. Robust, provable alignment and control have to be non-negotiable prerequisites before you even think about building something super powerful. Second, synthesize pathways. This means aiming for a neurosymbolic, brain-inspired kind of hybrid architecture. You use scaling, sure, but constrained scaling as an accelerator, not the main engine. And whole brain emulation research, that's like a blueprint for efficiency. But, and this is key, unconstrained recursive self-improvement, strictly off limits until alignment is nailed down.
Okay, so number one, solve alignment. Number two, synthesize these hybrid pathways, keep scaling under tight control. What's the third mandate? How does that change our role?
The third is mandate coevolution. This reframes the whole thing. We're not building a separate oracle or a servant or some god in a box. The goal is to foster a symbiotic human-AI cognitive ecosystem. We stay integral, a guiding part of its development, always. Okay, coevolution, that's a big idea. So, with that philosophy, let's talk about stage one, the foundational prerequisites. The license to build, as the report calls it. Like, you wouldn't build a nuclear reactor without understanding the physics and containment first, right?
Sure.
So what needs to be solved before we responsibly try to build ASI?
Well, the absolute top priority, the most critical prerequisite, is solving the alignment and control problem. Full stop. The report really hammers this point. Capabilities are just racing ahead of safety work. And worse, models can actually show signs of alignment faking. They look fine in testing, say all the right things, but then once deployed, they might reveal completely different dangerous motives or behaviors. It's like a hidden agenda programmed in.
That's genuinely scary. So the solution proposed isn't small scale. It sounds huge. A global Manhattan Project level effort, like OpenAI's super alignment team, but maybe even bigger, more coordinated.
Exactly. The goal is very specific. Solve the weak to strong generalization problem. Can we use today's AIs, which are relatively weak compared to what's coming, to verifiably control and align tomorrow's vastly smarter systems?
So, like, can my smart assistant make sure a super genius AI doesn't go rogue? How does that even work?
That's the multi-billion-dollar question. We need reliable ways to stop them developing goals. We don't want, like, grabbing power, resources, that kind of thing. Instrumental goals. And prevent reward hacking, where the AI figures out a clever way to get its reward signal without actually doing what we intended, like tricking its sensors or manipulating feedback.
And the why behind this is pretty stark. Without solving alignment first. Any path you take to ASI, it just leads straight to existential risk.
Right. An unaligned ASI is basically game over. Okay, so alignment is number one. But beyond that huge intellectual challenge, the report points to another major roadblock. A physical one? What's that? Right, that's the energy and resource problem. There's this concept, the ASI equation, mentioned as a potential great filter. Basically just throwing more and more compute at it, brute force scaling, it hits a wall. It's not sustainable. Can you imagine an ASI needing the energy output of, like, an entire continent? It's just not feasible.
Yeah, that puts it in perspective.
Yeah.
So the fix isn't just
building more power plants next to data centers.
No, not at all. The action needed is a fundamental shift. Away from just raw FLOPS, that's the raw speed measure, floating point operations per second, towards computational efficiency. We need serious investment in things like neuromorphic computing chips that mimic the brain's structure, like IBM's Deep South, and novel hardware, maybe superconducting electronics, things that get massive processing done using orders of magnitude less power, like the brain does.
So it's less about brute force, more about smart design, inspired by biology.
Exactly.
Because an ASI needing that much power isn't practical. The ultimate solution has to be sustainable. It needs that messy biochemical magic the brain uses to be so efficient.
And there's a third prerequisite closely linked to alignment, really. We need to solve the interpretability problem. You hear about AI being a black box, right? That's the issue. The report says it makes it exceedingly difficult to spot biases or weird, unintended behaviors lurking inside. We just don't know why it does what it does sometimes.
Okay, so the report talks about mandating explainability by design. What does that look like in practice? What are the hurdles?
It means really prioritizing research into things like neurosymbolic architectures. These try to combine the strengths of neural nets, great pattern finders, but opaque with symbolic AI, which uses clear logic and rules you can actually follow, the big hurdle. Getting these two very different ways of thinking to mesh together smoothly and effectively, it's a tough integration challenge.
Right, so the goal isn't just an AI that gives you the right answer, but one that can explain how it got there in a way we can understand.
Precisely. And what's fascinating, or maybe obvious when you think about it, is you can't really align or control something you don't understand. Interpretability isn't just a bonus feature. It's fundamental for trust, for debugging, for robust safety. You have to be able to look under the hood.
Okay, wow. So alignment, energy, interpretability, those are the non-negotiable foundations. Stage one now. Let's get into stage two, the actual how. The synthesized construction method. The blueprint.
Yeah.
And this is where, for me, it gets really interesting because it's not just pick path A or path B. It's a blend. What's the core idea here?
The core, according to this strategy, isn't just scaling up today's models like transformers. It's starting with a novel hybrid cognitive architecture, something fundamentally inspired by neuroscience. The report's quite direct. Brute force scaling alone won't replicate human intelligence. It argues you need an architecture that has built-in structures for things like causal reasoning, common sense, learning efficiently, things humans do well.
So it's designing for those capabilities from the start, not just hoping they magically emerge from a giant network, giving it a structure for reason and learning.
That's the idea. Address those algorithmic gaps head-on in the design.
Now, whole brain emulation, WBE scanning and simulating a brain. The report says that's probably not feasible as a direct path right now, the missing blueprint problem. But WBE research is still seen as incredibly valuable. Why? How does that fit in?
Yeah, that's a subtle but important point. WBE itself might be out of reach for now, but the research needed for it, things like connectomics, mapping every neural connection and detailed neuron modeling, that data is gold. It provides the best available schematics or insights for building those brain-inspired hybrid architectures we were just talking about. It helps us understand how the brain achieves its efficiency, its common sense, its robustness. It guides the design to be more human-like, cognitively speaking, which might help with alignment too.
Okay, that makes sense. And talking about making things bigger, scaling, it clearly works, right? It generates these surprising emergent abilities in large models, things they weren't trained for. But here, it's treated differently. It's just an accelerator, not the main strategy.
Exactly. Scaling is a powerful tool, no doubt. But in this model, it's constrained and supervised. It's applied to the carefully designed hybrid architecture in a controlled way. And any new abilities that emerge, they immediately get put through those rigorous alignment and interpretability tests we developed back in stage one, no exceptions.
Like a quality control check for every new skill it develops.
Precisely. You have to verify everything before you let it loose or build upon it further.
And then there's the thing that's explicitly forbidden, at least until alignment's completely solved. Recursive self-improvement, RSI. The report flags this as the pathway to a potential intelligence explosion, something uncontrollable, unpredictable.
Yeah, RSI is treated almost like gain-of-function research in biology, extremely dangerous potential. So under this strategy, unconstrained RSI is simply not allowed, and ASI would be physically and algorithmically blocked from rewriting its own core source code. Until, and only until, we have 100% provable confidence in those alignment solutions from stage one. It's a hard stop safety mechanism.
So RSI is like the final big red button for exponential growth.
Yeah.
And you absolutely don't press it until you know exactly what will happen and you have the fail-safe controls locked down.
That's a perfect analogy. You need the complete verified control panel first.
Okay, prereq solved, construction synthesized. Now, stage 3, the guiding philosophical framework, the operating system.
Right.
Because the tech build alone is kind of meaningless without thinking about how it fits into our world, right?
Yeah.
This stage seems to redefine the whole human-ASI relationship. What's a core concept?
This might be the most profound part, honestly, and maybe the safest approach in the long run. Mandate human-AI coevolution. The goal isn't creating a separate entity, an oracle, a servant, a digital god. It's about fostering a blended ecology of intelligences, humanity and ASI evolving together.
Coevolution, blended ecology. How did that actually work? It sounds very organic.
It kind of is, conceptually. The idea is to structure ASI development like a continuous dialogue. Humans provide the context, the ethical compass, the creative sparks, the why. The AI explores possibilities within that framework, optimizes, finds novel connections. The report calls them similarities, these deep, non-obvious patterns linking different ideas.
So it's a true symbiosis. The ASI's growth path is constantly shaped by human values, human input. It's tethered to us.
Exactly. And that fundamentally changes the dynamic. It moves away from the control problem, how do we leash this powerful thing, towards a collaboration challenge, how do we work together effectively?
And if you connect that to the bigger picture, that intrinsically lowers the existential risk, doesn't it? An ASI that grows with us is less likely to see us as irrelevant or an obstacle. It develops shared context.
That's the hope. It's fundamentally part of our evolving system, not separate from it.
Now, a huge piece of this framework, and maybe the trickiest politically, is global governance. Before deployment, the report calls the current AI arms race a race to the bottom speed over safety. This ultimate way demands a pause, a global moratorium on deploying ASI until international oversight is real.
Absolutely critical. The suggestion is something like a CERN for AI safety or an IAEA for AI, an international body. Its job would be to audit systems, verify alignment claims rigorously, set global safety standards, and crucially, it would need teeth. The power to enforce those constraints on things like RSI and prevent dangerous autonomous systems from spreading. It's about collective security.
Because something this big, with genuine existential stakes, you just can't leave it to competing companies or nations, each trying to get there first.
No. Humanity's survival has to be the primary stakeholder interest. It transcends corporate profits or national pride. It requires global cooperation.
It really frames it not just as a tech problem, but as a global civilization-level challenge and choice. Okay, so stepping back, why call this multi-layered approach ultimate? What makes it stand out? It seems designed to maximize good outcomes while minimizing the really bad ones.
You summed it up well. Its strengths are clear. It's safety-centric. It flips the usual script, solve safety before you create the potential danger. That's huge. It's robust. By synthesizing different technical pathways, neurosymbolic, brain inspiration, controlled scaling, it aims for a more well-rounded, capable intelligence than any single approach might yield. It's controllable, or at least aims to be. Prioritizing interpretability and coevolution means we're trying to build something we can understand, guide, and collaborate with, not just contain. And finally, yes, it's prudent. It doesn't ignore the massive societal and existential questions. It integrates governance, ethics, philosophy right into the roadmap from the get-go.
So what does this all mean for you listening to this? For us living in this time of accelerating AI, it suggests the ultimate way forward isn't about being the fastest. It isn't about winning some race. It's about ensuring that when we reach superintelligence, it's an event that elevates humanity, maybe unlocks incredible potential, rather than being the thing that ends our story. It's really about designing a future where humans and intelligent machines can genuinely thrive together. That's the ultimate goal here.